Good evening and welcome back, everybody. Glad to see y'all again. It is day 8 of the Advent of Code, and I am getting an early start today. We see our expedition has come across a peculiar patch of tall trees, all planted carefully in a grid. They've explained to me that a previous expedition planted these trees as a reforestation effort. They are curious if this would be a good location for a treehouse. They want us to determine whether there is enough tree cover here to keep a treehouse hidden. To do this, we need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree, which will be our puzzle input for the day. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and one edge of the grid are shorter than it. Only look up, down, left, or right from any given tree. We need to see how many trees are visible from outside the grid. Our puzzle input is pretty basic today, just a large square area of random numbers here that we can use to calculate. So we'll go ahead and use this and get right into it. Alright, so we are back here in our VS Code. We have our input 8.txt, all of our input pasted in right here, and we are ready to begin. So we'll go ahead and start writing out our parser. Pretty simple today. We just need to return a two-dimensional list of the integer of each value in our input, which we've done right here, where we return the integer for each tree. Now we can go ahead and start writing our process for the day. And since we're keeping track of the visible trees, we need to hold that there as our result, and then we will start looping through each of our trees. We will get our row index based on the length of the trees that we are taking in as an argument up here. We'll get our row using the row index on trees. We'll get our tree index based on the row, and our individual tree will be equal to the row and tree index. Now, of course, we need to check each direction for each tree. So what we're going to do is we're just going to create a list of lists right here, where each list will be a slice of the trees in that direction. For going east, we can just take a slice here. Same with our going west. Now going north and south is a little bit more complicated here since we're looking at the column instead of the row. So for that, we just use a list comprehension where for each row, we take the value at the tree index and then we take a slice of that value right here. The same applies for going south. From here, we need to loop through our directions and check and see if the tree is visible in any of them. Now to do that, all we need to do is check each of these lists, and if any of these lists has a selection of trees where each tree is lower than the tree that we're looking at, then that'll mean that the tree is visible. So to do that, we'll just use an if statement, and we will check if not any on a list comprehension where we check other tree is more than or equal to our current tree for other tree in directions. And if that value is true, we can simply increment our visible trees and we can break out of our for loop. At this point, we should be able to just return our visible trees, and that should be our value. So let's go ahead and give this a try. Whoops, minor error there. We have a typo up here. We use directions instead of direction, which is what we want to use. So take that S away and try again. And we have a value of 1,688. So let's head over to the Advent of Code and give that a try. Alrighty then, we are back here in the Advent of Code. So let's go ahead and put in that value we just got and see what we have. We have the right answer, and we are good to move on to part 2. Alright, content with the amount of tree cover available, the elves just need to know the best spot to build the tree house. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from that tree, and stop if we reach an edge or at the first tree that is the same height or taller than the tree under consideration. A tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions. So for example, in the tree above, this is 4, found by multiplying 1 times 1 times 2 times 2. So considering each tree on the map, what is the highest scenic score possible for any tree? Alright, let's go see if we can work through that. That should be able to be pretty easy given our current code setup. So we are back here and we are going to start defining our process too. Now I think for this we can actually just use a modified version of what we built above. In fact, you know what? We're just going to go ahead and copy all of this down and paste it into here, and then we'll start using that as a base. For For starters, instead of looking at a visible tree, we want to look at what the value of the best tree is. Down with our tree here, we need to keep track of the score of the current tree we're looking at, which we'll set to 1 since we're going to be using multiplication. Then for our directions here, since it's going to matter the order that the trees are in, we're going to be needing to look from the tree outwards. So to do that, we're going to need to reverse a couple of these. We should have that one reversed and this one down here reversed. Now we can delete this bit here. We'll need to keep track of the current visible trees for the particular tree. We'll loop through our other trees. And we know for sure that at least one will be available, so we'll go ahead and add one and say that if other tree is more than or equal to current tree, we will break. Then at this point, once we have broken out of that, we need to multiply our score, since that's what they wanted to calculate, by the number of visible trees. Lastly, we do some comparison between the current score and the current best tree. If score is more than best tree, we want to set best tree equal to that current score. And then at this point, we can simply return the best tree. Let's give this a shot down here. 410,000. Let's head over to the Advent of Code and give that a try, shall we? And we are back here once more with that value, so let's go ahead and paste it in right here and see what we get from this. We have ourselves the right answer. Woohoo! We are 1 gold star closer to collecting enough starfruit, and we have completed day 8. Alrighty then, that was a quick day, but that'll about wrap it up for me. Thank you guys so much for watching. As always, if y'all enjoyed, please consider leaving a like or a comment, as that would be absolutely amazing. I'll have the code in my GitHub and the link to the repository down in the description below. Thank y'all so much for watching, and until tomorrow, I will see y'all later. Goodbye!